All right, so now we're going to be looking at graphing systems of inequalities, which means there's going to be more than one inequality on a graph. So let's take a look at those really quick. We got a system of inequality already graphed here, and this is what it ends up looking. As you can see, you have an inequality right here that's green color. It's shaded above, and it's a solid line. But we also have this bluish inequality right here that's got a solid line, and it's also shaded above. So what a system of inequalities does is it has to be basically a solution for both of those linear inequalities. And that way it would be a solution to the whole system. Just like we were at equations. We were looking for a solution to one equation and the other, and then when they overlapped, where they intersected, is what the solution was to the system. Same thing here, where they overlap is where the solutions are to the whole system. All right, so go ahead and you should probably pause the video, and write down everything on this screen, because we're going to go through all of these examples and talk about whether or not these ordered pairs are solutions to this graphed system of inequalities. All right, hopefully you paused it and did that. The solution to a system of linear inequalities consists of all the ordered pairs that satisfy the linear inequalities in the whole system. So if there's two inequalities, we're looking for a point that is a solution to both. All right, so let's just take a look at our first one. Our point A right here is the point 0, 0. And that point is right there. That is a solution to one of the inequalities, but not both, and therefore it is not a solution to the system. The point 5, 8, so 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8 right there is a solution to both inequalities, therefore it is a solution to the system. 1, 4, 1, 2, 3, 4. Is a solution definitely to this green inequality here, but this inequality right here, it looks like it could or could not be. This is where we have to talk about solid and dotted lines, and because it's on a solid line, it is a solution to the blue inequality, and therefore is a solution to both inequalities, and therefore the whole system. 4, negative 3, 1, 2, 3, 4, 1, 2, negative 3. That's not a solution to either inequality, and therefore not the system, so you're out. 0, 10. Would be right there. That's definitely a solution to both. It's a solution to the green and the blue inequality. So this is a solution. 8, 2 over 8 up 2. That one could be tricky. It is a solution to the blue inequality, but not the green one, and therefore not a solution to the system. 8, negative 7. 8, negative 7 is about right there. That's not a solution to either, so not the system either. Negative 10, negative 10. Negative 10, negative 10 is a solution to the green, but not the blue, so not a solution to the system. What about 10, positive 10? So 10 is right here. That is a solution to the green inequality as well as the blue. That's a solution to the system. Now we're going to get outside the box here, quite literally. Now we have to start thinking, where are the solutions when we're not even looking on here? What if we start going outside the box? 0, 100. Remember, 0 means don't move left to right, and then move up 100 steps, right? Well, that's definitely going to be in my double shaded region. That would be a solution to the blue inequality and the green inequality. What about negative 50, negative 251? Well, if you remember, that would be down here in this quadrant, because everything down here is negative, negative. If I went this way, negative 50, and then I went down negative 251, I would be in this quadrant. But you notice there's no blue solutions here, right? All the solutions are up this way, not down this way. So it might be a solution in the green one, but it's definitely not blue. So that's not going to be a solution to either of these inequalities. 10, 27 means you have to go over 10 and then up 27. But you can see as long as it's above like 9, you're definitely going to be a solution here. So that's going to be a solution as well. Let's take a look at our next slide. All right, so here we go. We have two inequalities that we'll need to graph onto our coordinate grid here, and then we're also going to need to do dotted and solid lines as well as also shading above or below. And we've got some reminders up here on how you do that. Let's go ahead and take a look at our first one. I'm going to go with red to do our first one. I'm going to go ahead and take a look at that. The slope is, let's move out of here for me. Cool. The slope is a negative 2, and the y-intercept is 3. So I'm going to begin at 3 on the y-axis, and I'm going to move with my slope of negative 2. So that's going to be a run 1, but rise -2. And I should end up with that negative slope. I can also go the other direction because I want to keep a nice clean line. I'm not going to go and draw a solid line right away because I need to ask myself, does this have a solid line? Is the line included or not included? Here I see that it says less than or equal to. And because it's equal to, we do give it a solid line. That means that the line is including our solutions. Let's go ahead and draw that line as a solid line now. And now I just need to ask myself, do I shade above or do I shade below? Well, greater than or equal to, right? Oh, sorry, this one's less than or equal to. Less than or equal to is right here. We are going to shade below the line. You can think about that this way, less than the line. What's smaller than the line? What's below the line? If you took somebody, maybe that's Xavier. Can this be Xavier? Sure. Xavier tries to go and climb the line on this side. What's going to happen? I mean, is he gonna be on top of something or below it? He's below it. He's just going to fall, right? But if he's on top of the line, he'd be on this side and he'd just skate right on down the positives, that negative slope, right? So this is below the line. This would be above the line. And we need to shade less than is below. So we're going to shade this side of the line. And you don't need to go all crazy on your shading. Something like that is simple enough to let us know what's going on.
In fact, don't do scribble scrabble because that makes it hard to identify the two different lines.
It will. Let's take a look at this one now. We're going to do this one in blue. We've got our slope here of how 1/2. That's how we will move. And we got my y-intercept here of 2. That's where we're going to begin. Let's go begin. At 2. We're going to rise 1, run 2, or run 2, rise 1. And get that slope all graphed on there nice and neat in both directions so that we can draw a nice straight line. But before I draw the line, I need to ask myself, is it an included line or is it an excluded line? Well, this one says y is greater than, no equal to. So whether it's greater or less than, it gets a dotted line. That means that the line is not including the solution. So let's get some dots through there. And now we need to shade above or below. This is greater than. Just like we talked about it before, greater than, right here says to shade above the line. Anything greater than the line is going to be above it. And if we bring Xavier back over here, above the line is going to be the side that he can walk on. If he's below this line, he's just going to fall. So above the line is what we need to do because it's greater than. We're going to shade above this way. And now we can tell where these solutions are overlapping. We have the solutions to the red inequality, the solutions to the blue inequality, and the solutions to the entire system. The questions that you need to ask and be able to answer are, where are the solutions? They're going to be right here, right here in this double shaded region. Write down 3 solutions. Well, why don't you go ahead and pause the video and see if you can write down 3 solutions to that. All right, well, I'll name off 3, and hopefully yours don't match mine because then you're just cheating. I'm going to go with, let's see here, -10, +10. That's definitely a solution. I'm going to go with -10, 4.
What about where they intersect, Mr. Nelson? Is that a solution?
Is that a solution right here where they intersect? Well, where they intersect, it would be a solution to the red one because it's on a solid line. However, it's not a solution to the blue because the blue has a dotted line. That means that the line is not included. It's excluded from our solutions. So where they're intersecting is a solution to red but not blue, and therefore that's not a solution. A lot of people try to go right for the intersection point. Sometimes it is, and sometimes it's not. If they're both solid lines, then it would be a solution. In this case, it's not because it's a dotted line. One of the lines is excluding it. So no, to answer Mr. Craig's question. One more point that I'd do, let's go -3, 1, 2, 3. -3, 3. That would also be a solution. Okay. So I got 3 solutions. The next thing is write down 3 non-solutions. So we just talked about one actually, right there where they intersect at 0, 2. That's not a solution. We talked about why. Let's talk about way over here. Let's just go right there. Smack dab, not a solution to either of them. So it's going to be at 10, 0. And then we can even go up here to 10, 10. That's not a solution to the red one, the red inequality, so it's not a solution to the system.